Having understood the definition of odd days and the reference chart which helps us in finding out the day of the week based on the number of odd days in a given period, let us now calculate the number of odd days for longer periods. For example, let's calculate the number of odd days for the first century, for the first 100 years, starting from 1st January of the first year to 31st December of the 100th year. So we are now going to calculate the number of odd days for the first century. Right, first century. So 100 years. What will be the number of odd days in 100 years? Now the number of odd days in the first 100 years would depend on the number of leap years and ordinary years in this period of 100 years. Now we know that leap years occur every 4 years. So to find out the number of leap years in the first 100 years, we'll simply divide those many years by 4 and check how many times do we get 4 in that period. So when we divide 100 by 4, we get 25, which means there should be 25 leap years in the first 100 years. But remember, 100th year, that is the last year in this period, is a century year, and we have discussed that for a century year to be a leap year, it must be divisible by 400. 100th year or 100 is not divisible by 400, which means the last year, 100th year, is not a leap year. So if you now understand, in the first 100 years there will be only 24 leap years, right? There will not be 25 leap years. Don't simply divide 100 by 4 and say 25 leap years. The 100th year was not a leap year because it is a century year, and for a century year to be leap year, it must be divisible by 400, which is not satisfied in this case. So in the first 100 years we have 24 leap years and the remaining 76 were ordinary years. And we know that in each ordinary year we have one odd day, and in each leap year we have 2 odd days. So based on this, let us calculate the total number of odd days for the first 100 years. So in the first 100 years we know there were 76 ordinary years and 24 leap years. Now we know that in each ordinary year there is only one odd day. So the total number of odd days would be 76 into 1. Plus in each leap year we have 2 odd days. So total number of odd days in 24 leap years would be 24 into 2. Now 76 into 1 is 76, 24 into 2 is 48. 76 and 48 would be 124. So altogether we have 24 odd days in the first 100 years. That means in the first century, from first year to the 100th year, there were 124 odd days. But again, 124 odd days can be taken as some number of complete weeks plus extra number of days. For example, 124 here would be 17 weeks because 17 into 7 is 119. So 119 days is equal to 17 weeks. So 119 days plus 5 days, where 119 days can be taken as 17 weeks. So if we try to split 124 days in terms of number of complete weeks and additional number of days, we will get 17 complete weeks plus 5 days. And since we know that the number of odd days is the number of days more than the complete weeks, we can say there were 5 odd days in the first 100 years. So clearly in the first century or for the first 100 years, we'll have 5 odd days. There were 5 odd days in the first 100 years. Now we know that the number 5 in terms of odd days represents a Friday. So if you understand, the first day of the first year, right, 1st January of the first year was a Monday, and we have taken the reference as the previous day, Sunday. Sunday is 0 odd days, Monday is 1 odd day, Tuesday 2 odd days, and so on. Now since we have got 5 odd days and we know that 5 represents a Friday, we can say that in this period of 100 years, the last day, that is 31st December of the 100th year, was a Friday. So this is how calculating the number of odd days will help us in finding out the day of the week for the last day of the given period. So we can say the last day of first century. Last day of the first century. What was the last day of the first century? 31st December of the 100th year was a Friday. And how do we know it was a Friday? Because in the first century we have 5 odd days. In the first 100 years we have 5 odd days. So this way we can always calculate the number of odd days for the given period, and based on that we can decide the day of the last date. So this is how to find out the day of the week for the given date. We need to understand the number of odd days from the starting point, and that number of odd days here will help us in finding out the day of the week. Let us continue this calculation of number of odd days for the first 200 years, first 300 years, and so on. We have already calculated that in the first 100 years, that is in the first century, there were 5 odd days, which implies the last day of the century was a Friday, because 5 means Friday, 5 odd days means Friday. Let us now do the calculation for first 200 years. So what will be the number of odd days in the first 200 years? Now we know that in the first 100 years there were 5 odd days. In the first 200 years there will be 5 into 2 odd days, because the first century and the second century would have same number of leap years and ordinary years. So if there were 5 odd days in the first 100 years, there will be equal number of odd days in the second 100 years as well. So the total number of odd days in the first 200 years will be equal to 5 into 2, which is equal to 10 odd days. Which means in the first 200 years there were 10 odd days. Now 10 odd days again can be split as 1 week and 3 days, and therefore we can say the number of odd days in the first 200 years were 3, and 3 odd days means the last day was a Wednesday. So we can now say that the last day of the second century was a Wednesday, because starting from our reference point, which was a day before 1st January of the first year, to the last day of the 200th year, we have got 3 days, 3 odd days, and 3 odd days indicates a Wednesday. So the last day of the 200th year was a Wednesday. So last day of the 100th year, 31st December of the 100th year was Friday, and 31st December of the 200th year was a Wednesday. Let's continue and see the number of odd days for first 300 years. So the number of odd days in the first 300 years. Now going by the same argument that since there are 5 odd days in the first 100 years, the number of odd days in the first 300 years would be 5 into 3, since the number of leap years and ordinary years is same for the first century, the second century, as well as the third century. So total number of odd days would be 15. We have 15 odd days, but 15 odd days can again be split as 2 weeks. 2 weeks will be equal to 14 days and 1 additional day. So we can say the actual number of odd days in the first 300 years is only 1. There is only 1 odd day, and 1 indicates Monday. So we can say the last day of the 300th year was a Monday. So if you try and observe from 0th year to the 100th year, there were 5 odd days. So we got the last day of the 100th century, last day of the 100th year as Friday. From 0th year to 200 years, there were 10 odd days, or simplified as 3 odd days. So the last day of the second century comes out to be a Wednesday. And from 0th year to the 300 years, we have total 15 odd days, which can be simplified as 1 odd day. And 1 odd day indicates that the last day of 300th year was a Monday. Now let us do this for the first 400 years. Let's see what happens. In the first 400 years, now if you observe, in the first 400 years, we will have 5 into 4, because each 100 years we have got 5 odd days, right? So for first 400 years, we will have 5 into 4 plus 1 odd day. Total number of odd days will be 5 into 4 plus 1, which is equal to 21 odd days. Now you may get it out. Why are we taking plus 1? Understand, the reason here is 5 into 4 is regular, like what we have done 5 into 2, 5 into 3 for first 200 years and first 300 years. Same way 5 into 4 for the first 400 years. But remember that 400th year was also a leap year. Yes or no? 100th year was not a leap year since it was not divisible by 400. 200th year was also not a leap year as it was not divisible by 400. And 300th year was also not a leap year as it was not divisible by 400. Right? You know that for a century year, 100, 200, 300, 400, for a century year to be leap year, it must be divisible by 400. So 100, 200 and 300 were ordinary years which had only one odd day. If you take simply 5 into 4, we are considering the 400th year also as an ordinary year. But we now know that 400th year is a leap year since 400 is divisible by 400. That means this 400th year will have one more day than an ordinary year. So that is the reason we have taken plus 1. Actually, a leap year has 2 odd days. But understand, one of those odd days for the 400th year has already been considered in this part, 5 into 4. The additional odd day has been taken here. So that is the reason we have total number of odd days for the first 400 years as 5 into 4 plus 1, which is 20 plus 1, 21 odd days. Now 21 odd days is as good as 0 odd days because 21 odd days can be taken as 3 complete weeks. 3 complete weeks plus 0 days. And 0 days, which means in the first 400 years we have number of odd days equal to 0. 0 odd days indicate that the day was Sunday. So now we can say that the last day of the 400th year was a Sunday, which means 31st December of 400th year was a Sunday, because the total number of odd days from 0th year up to the 400th year is equal to 0, and 0 indicates Sunday. So the point to be noted is, because in the first 100 years we have 5 odd days, the last day of the first century was Friday. In the first 200 years there was only 3 odd days, so the last day of the second century was a Wednesday. The first 300 years had only 1 odd day, and hence the last day of the third century was a Monday. And the first 400 years had 0 odd days, so the last day of the 4th century was a Sunday. And now that we have got 0 days for the first 400 years, we can say that this cycle of number of odd days will repeat itself. Because if you remember, we started from a reference point which was 0th day, the day before 1st January of the first year. It was a Sunday, and that was the reference for us. So we started from 0 odd days, and again we have reached 0 odd days in the first 400 years. So which means now the cycle is going to repeat. So now again, if you take the 400th year as the reference point, the last day of the 400th year as the reference point, it was a Sunday. Now what will be the number of odd days in the 5th century? The number of odd days in the 5th century will be equal to the number of odd days of the 1st century, because total number of odd days in the first 400 years is 0, and number of odd days in the next 100 years would be 5. So 0 plus 5 is 5. So we can say the number of odd days in the 5th century would be 5, and hence the last day of the 5th century will be a Friday. What will be the number of odd days in the 6th century? Understand, the number of odd days in the 6th century will be 5 again, because for every century where the century year is not a leap year, the total number of odd days will be 5. But starting from our reference point, we will say the number of odd days in the first 600 years will be only 3, because the number of odd days in the first 600 years will be equal to number of odd days in the first 400 years plus the number of odd days in 200 years, which is 3. So 0 plus 3 is 3. So total number of odd days in the first 600 years is 3. Number of odd days in the 6th century will be 5. Understand, the number of odd days in the 6th century will be 5, but the number of odd days in the first 6 centuries or in the first 600 years will be 3. So the last day of the 6th century will be a Wednesday. The last day of the 7th century will be a Monday. And again the last day of the 8th century will be Sunday. And this cycle continue to repeat itself. So if you say what will be the last day of the 9th century? 9th century's last day will be Friday. The last day of 10th century will be Wednesday. Last day of 11th century will be a Monday. And last day of 12th century again will be Sunday. And the cycle repeats. So the conclusion that we can make here is, if you observe, the last day of any century will either be a Friday or Wednesday or Monday or Sunday. It will never be any other day of the week. What are the remaining days here? Tuesday, Thursday and Saturday. So that's an important point now. The last day of a century can never be a Tuesday or a Thursday or a Saturday. It should be either a Friday or a Wednesday or a Monday or Sunday. And the other important point that we can observe here is the last day of every 4th century will be a Sunday. Yes or no? 400 years, Sunday. Last day of 8th century, Sunday. Last day of 12th century will be Sunday. 16th century, Sunday. Last day of 20th century will be again Sunday. 20th century was the year 2000. So 31st December 2000 was a Sunday. Again 31st December 2400, which is about 400 years from now approximately. So again 31st December 2400 will be a Sunday. So 2 important points, or I can say 3 important points. Last day of a century will be any of these days: Friday, Wednesday, Monday or Sunday. So it means it cannot be Tuesday, Thursday or Saturday. So these are the 2 important points: what can be the last day, what cannot be the last day. And the third point is the last day of that century which is having a leap year as its century year will always be a Sunday.